Hey guys, welcome to our video for 6.1b. Today we're going to look more at simplifying exponent expressions. So I'd like you to take a moment to pause the video and set up your note sheet with the section, the date, and the I can statement, and then resume your video as soon as you're ready. Alright, so today we're just going to practice a number of exponent expression simplifying problems and then look at some of the different exponent rules. Now, if you would like, when I put up each problem, you could pause the video and try the problem first to see if you can come up with the right answer before I work through the problem. And that might be a nice way to test yourself and see how well you're remembering the exponent rules from pre-algebra. So our first problem is a pretty straightforward one. 2 cubed x squared all raised to the fifth. So if you'd like, you can pause the video, try it on your own, and then check to see how you did. And you can do that for each problem if you would like. So if I was solving this problem, I would distribute the 5 to both of these. And so I would have 2 to the 15th, x to the 10th. And then the final step here would be that 2 to the 15th is a rather large number, 32,768 x to the 10th. Now you can use your calculator for something like 2 to the 15th if you would like, but I would like you to actually do multiply out the exponents when they are attached to coefficients. All right, so our next problem, and again you can pause if you would like to. So x to the 5th y squared over x to the 4th y to this nothing. Now, this is a problem that uses the division rules for exponents, which, if you remember, division means that we subtract the exponents. So this is really the same thing as x to the 5 minus 4 times y to the 2 minus 0. In other words, this is the same thing as xy squared. All right, our next problem here. We have x to the negative first, y, x, y to the negative second. So again, we're using division rules. So we've got x to the negative 1 minus 1, because x on the bottom has an exponent of 1. And then we have y to the first minus negative 2. So this is the same thing as x to the negative 2 y cubed. However, our answer has to have only positive exponents, so we need to remember to flip the sign and go across the line. So in other words, this is the same thing as y cubed over x squared. So a few more steps for this problem because of those negative exponents. All right, our next problem here. 4x squared y to the 5th all to the negative second. So we're going to start with the power to the power rule. We're going to distribute the negative 2 all the way through. And that gives us 4 to the negative second, x to the negative 4th, y to the negative 10th. Now, because all of these have a negative sign, they're all going to flip to the denominator. So this is the same thing as 1 over 4 squared x to the 4th, y to the 10th. Now the last step here is to turn 4 squared into 16. So your final answer would be 1 over 16 x to the 4th, y to the 10th. All right, so getting a little bit more complicated as we move along. 2x squared y over 6xy to the negative first. So the thing that makes this one interesting is that we have some coefficients here that we have to treat as a fraction rather than using any exponent rules. So for me to start this problem, the first thing I would do is just simplify the coefficients. 2 over 6 is the same thing as 1 over 3. Now with the exponents, we've got division, so we're going to subtract the exponents for all these variables. So this is the same thing as x to the 2 minus 1 y to the 1 minus negative 1 all over 3 in the denominator. I can ignore the 1 in the numerator because it's just a 1. So now if we do our subtraction, we're going to end up with x y to the 1 minus negative 1, or 1 plus 1, so y squared over 3 as our answer for this problem. All right, so our next problem, getting even a little bit more advanced here. So we've got two terms, xy to the 9th over 3y to the negative 2 times 20 x to the 14th over xy to the 6th. There's a few different ways that you can approach this problem depending on how you would like to simplify it. So I'll show one way, but you might do it a completely different way, and that's absolutely fine. The way that I'm going to approach this problem is I'm going to simplify each term separately first and then combine them. So for the first term, we have x y to the 9 minus negative 2 over 3. And for the second term, we have 20 x to the 14 minus 1 over y to the 6th. So this is the same thing as x y to the 11th over 3 times 20 x to the 13th all over y to the 6th. So now if we go to simplify this problem, we are going to end up with, so we're going to simplify here, and the 20 over 3 doesn't change at all. So I'm just going to start out with 20 over 3. Now, y to the 11th y minus y to the 6th is going to be y to the 5th. And x times x to the 13th is just x to the 14th, because it's 1 plus 13. So our final answer here would be 20x to the 14th, y to the 5th, all divided by 3. So our next problem here is 12xy over 7x to the 4th times 7x to the 5th y squared over 4y. So maybe this time I'll do it the other way, just to change it up. So one thing I'm going to notice here, though, right away, is that we have a 7 in the numerator and the denominator. So I'm just going to cancel these out right away. Similarly, we have a 12 in the numerator and a 4 in the denominator, which is the same thing as 3 over 1, just to make things a little bit easier here. So this time, let's combine all the numerators and all the denominators first, just to show you a different way that you could approach this problem. So in the numerator, we would have 3x to the 1 plus 5, y to the 1 plus 2. And in the denominator, we have no more coefficients, so we just actually have x to the 4th y. So this is the same thing as 3x to the 6th, y to the 3rd, over x to the 4th y. So now we can just use our division property to subtract. So we have 3x to the 6 minus 4, y to the 3 minus 1. And that's the same thing as 3x squared y squared. Just a few more steps to this problem, but nothing too difficult. All right, another example here, getting a little bit more complicated. We have power to the power and multiplication. So I'm going to start this problem by distributing the powers first. And notice that the powers distribute to the numerator and the denominator. So here we end up with x to the 8th over y to the 12th times y to the 10th over x to the 6th. And since now we're looking at division, we have x to the 8 minus 6 times y to the 10 minus 12, which is the same thing as x squared y to the negative 2nd. But since we can only have positive exponents, we have to cross the line and change the sign. So we end up with x squared over y squared for this problem. All right, last but not least, our final example here, the most complicated one of all. We have a giant problem with a whole bunch of terms in the numerator and a whole bunch of terms in the denominator, all raised to the exponent of 0. And if you remember from your exponent rules book, no matter how complicated it gets, if it raised to the exponent of 0, the answer is 1. So this is actually a very simple problem if you notice that exponent. So that brings us to the end of our video. You're going to practice more exponent rule simplification problems on your homework tonight on your worksheet. Let me know if you have any questions.